Okay, well, finding maxima and minima functions of more than one variable is completely analogous, but with slight differences to what you do with functions of one variable. Function of one variable, you find your critical points and you test. Okay? Critical point is where your derivative is 0. Now we're talking about relative max and min, because for absolute max and min, you have to check your boundaries too. Okay? Okay? In okay, to get a critical point, if x has got to be 0, fy has got to be 0. Okay? Otherwise, you know, if fx is 0 but fy isn't, your parallelepiped looks like this. Clearly you don't have a max or min anywhere, right? Or if fx is not 0 but fy is, it's like this, and your parallelepiped's like this, and your truncated parallelepiped, right? It's truncated like this, right? Or like this. So if you don't have both partials equal to 0, you aren't going to have a critical point. And you're not going to have a max or min. Well, you're not going to have a max or min, so we're not going to call it a critical point. You know, that's, you know, the picture tells you that you don't have a max or min. Okay, so unfortunately that isn't sufficient, and that's the problem I assigned you. Okay? It's not sufficient. Well, another thing would be, even if you have derivative 0, both your partials would have to be the same sign. Okay? In other words, if it's level here, but you're concave up, and level in this direction, but you're concave down, you clearly don't have 0. You know, you go in one direction, function's increasing, you go in this direction, the function's decreasing. Either way you go, okay?
So what's fxx?
Partial of f with respect to x. Well, the partial with respect to x of the partial of f with respect to x. It's a second partial with respect to x.
Okay, so it's like the second derivative?
Yeah. Yeah, it's just straightforward. I'm sure you've seen that notation. I might not have used it in class, but I'm sure it's in your book. And it's so straightforward that I figure that I will talk about things that aren't. Okay? It's very easy to understand. But check your book. If it isn't in the sections I've assigned, you know, you should at least be scanning them and noticing things like that. Okay?
I missed one section. I still need to work on it.
Yeah, well, I might have screwed up the assignment somehow too. I'll look. But that's it. Okay? Anyhow, it's very easy, very straightforward. It means your second partial's got to have the same sign. It's got to be concave up in both directions or concave down in both directions. Yeah, there we go. Okay? Make sense? Still not enough. Okay? Because
Otherwise you have something like this, right?
okay, we'll see why this is not enough in a minute. There's a discriminant thing you got to take care of.